In our lesson today, we're going to investigate proportional and non-proportional relationships by using graphs. All right, our objective for today is to be able to recognize a proportional relationship by looking at a graph and state the unit rate in a graph. And what we've been doing over the past couple of lessons is using a table of values to determine if a relationship is proportional. We're going to build on that knowledge today and extend the information from the table to a graph and see if we can figure out if a relationship is proportional or non-proportional by looking at that graph. So looking at our first example here, okay, we have a table, and in the table it tells us a certain number of boxes and the weight of those boxes. And we want to know if there is a proportional relationship between the weight and the number of boxes. So we're going to start by doing what we've been doing in the last few lessons and setting up the ratios. In this case, what we're going to want to know is the pounds per box. So pounds to boxes. All right. And notice in the table, the first set of data is 0 boxes weighs 0 pounds. All right. That's pretty self-explanatory. If you don't have any boxes, then you don't have any weight. So we're not going to write that as a ratio. We're going to move to where we actually have some data, which is the second set starting right here. So remember, we're doing pounds to boxes. So this says that it is 4 pounds for 2 boxes. And if we get a unit rate out of this, divide both numbers by 2, we get 2/1. Our next rate from the table, it's going to be 8 pounds for 4 boxes. Simplifying that down to a unit rate, divide both numbers by 4, we get 2/1. The next one says that it's 12 pounds for 6 boxes. Divide both numbers by 6 to get the unit rate, and you get 2/1. And finally, it's 16 pounds for 8 boxes. Divide both numbers by 8. That's going to give us another unit rate of 2/1. Okay, so looking at the 4 unit rates, we noticed that they were all the same. They all were simplified down to 2/1. Remember that this simplified value is called the constant of proportionality, all right? So the constant of proportionality is represented here by the variable k, and each time we simplified it down, we got a value of 2/1, which is the same as 2. Okay, well, what does that mean? Well, that's where we write down the unit rate. Okay, the unit rate is going to tell us what 2/1 means. Remember that in the numerator, it was our pounds, and in the denominator, it was the boxes. So 2/1 means that it's 2 pounds per box. And that's what we're going to write here, 2 pounds per box. That is the unit rate. The unit rate is 2 pounds per box. The constant of proportionality k is 2/1, or 2. Since we had the same unit rate, there was a constant unit rate, the ratio of the number of boxes to total weight represents a proportional relationship. Okay, when you get the same constant unit rate, it is a proportional relationship. Now, these next 2 questions are new to us. It says, which quantity is the independent variable and which quantity is the dependent variable? And we need to figure out which is independent and which is dependent for when we do the graph in a little bit. Okay, so looking at the data from the table, we had the pounds and we have the boxes, all right? The weight of the boxes depends on how many there are. So the weight is going to be the dependent variable. The independent variable is the number of boxes. So which quantity is the independent variable? That's the number of boxes. You can have as many boxes as you want. The weight depends upon how many boxes there are. So the weight, which we measured in pounds, is the dependent variable. Notice that we use a variable to represent those. The independent variable is x and the dependent variable is y. So looking back up here when we set up our ratios, all right, the dependent variable was in the numerator and the independent variable was in the denominator. Okay, so now we know which one is the y value and which one is the x value. And that's going to be important because for a graph, we need to take our data and write the 2 quantities as ordered pairs. Ordered pairs are always set up as x comma y. The x variable goes first, the y variable goes second. So looking at our table of values, well, again, they were both started with 0, 0. So our first point that we plot on our graph later on is going to be 0, 0. The next one, all right, x comma y. X was the number of boxes, so it's going to be 2 comma 4. 2 boxes weighed 4 pounds. The next point is going to be 4 comma 8. 4 boxes weighed 8 pounds. The next one is going to be 6 comma 12. 6 boxes weighed 12 pounds. And finally, 8 comma 16. 8 boxes weighed 16 pounds. These are the 5 points that we are going to plot on our graph underneath. So now that we have our ordered pairs set up, we have to plot these on our graph that we see underneath. Before we can plot these points on the graph, there are a few things that we need to do, okay? The first thing that we need to do is always label the x and the y axis, okay? The x-axis goes horizontally, and it's this bolded line at the bottom of our graph where we see the arrow. I'm going to put an x right there. That's the x-axis. The y-axis runs vertically, and it's the bolded line that's all the way on the left side of our graph with the arrow. That's the y-axis. You're always going to label the x and the y-axis first. Okay, the next thing that we're going to do is title the axes. If you remember from before, the x data, if we look back up here, the x data was our number of boxes, and our y data was the weight in pounds. So let's go back to our graph, and on the x-axis, I'm going to label this the number of boxes. And for the y data, I'm going to label this as the weight. And in parentheses, I'm going to put pounds so that I know how I'm weighing the boxes. So you always label the x and the y-axis, and then you need to title them with their data. In this case, boxes and pounds. The next thing that we need to do is come up with a scale for the x-axis and the y-axis. Now, where the x and the y meet at this point right here, that point right there is called the origin, and it has coordinates of 0, 0. So this is 0 on the x-axis, and it's also 0 on the y-axis. What we need to do now for each axis is come up with an appropriate scale so that we can get all of the data from our table. So let's start with the x-axis, which was the number of boxes. If you look at your table, the biggest number of boxes right here, that was 8 boxes. So I'm going to go down to my x-axis and see what I can count by so that I can go up by 8. So here I am at the origin, and I'm going to try by going 1 line equals 1 box. So if I do that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I could get 10 boxes, but I only had to go up to 8. So I'm going to count by ones along the x-axis. Now I need to do something similar for the weight in pounds, which is our y data. If you look at the weight in pounds, the highest weight right here was 16 pounds. Okay, so if you go back to your y-axis, again, you start right here at the origin. This is 0. And if we counted by ones this time, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, well, we wouldn't be able to get up to 16. So I'm not going to count by ones. I'm going to count by twos. Every line is going to be worth 2 pounds. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, okay? On each axis, you need a consistent scale so that you can get all of the data from the table on your graph. Now we are ready to graph our 5 points, and let's remind ourselves of what those were. Our first was 0, 0, which was the origin, so put a little dot there. There's our first point. The next is 2, 4. Remember, it's x, y. So on the x-axis, we need to find 2. So I'm going to go to the right 2 units. And then the y value is a 4, so I'm going to go up till I get to 4, which is at this point right here. So that was 2, 4. Now I need to graph 4, 8, x, y. So I'm going to go over 4 in the x direction, and I'm going to go up 8 in the y direction. I'm going to put a point right there. That's the point 4, 8. 6 comma 12 is our next one. So again, I'm going to move to the right 6 units from the origin. And then I'm going to go up 12, which is this point right here, 6 comma 12. And then I'm going to go to 8 comma 16 with my last point. So I'm going to go to the right 8 units from the origin. And then up to 16, which is at this point right here, there's 8 comma 16. These are the 5 data points from our table. Now what we're going to do is draw a nice straight line through all of those points. So I'm going to use my line tool. There's my line tool. And I'm going to connect a line that goes all the way through my points, which looks something like that. And then the only other thing I need to do at the end of my line is put an arrow, because our data could continue if we had more boxes. So this is what the graph of our proportional relationship looks like. And there are 2 key features that we need to notice about our graph. Okay, so we're going to list those over here, number 1 and number 2. The first key feature of our proportional relationship is that this graph shows a straight line. Okay, so we're going to say next to number 1, the graph is a straight line. And our second feature is where the line starts. And the line starts right here at this point, which from before was 0, 0, which is called the origin. So number 1, the graph is a straight line. And number 2, the line starts at the origin. Okay, these are the 2 key features of a proportional relationship on a graph. It must be a straight line, and that line must start at the origin. If I see a straight line starting at the origin on a graph, I know that the relationship is a proportional relationship. What we want to do now is figure out what the constant of proportionality is for this example. Remember when we did the constant of proportionality up above, we simplified all these ratios down to 2 over 1. Remember right here, the ratios were set up as y over x. So when I do this to get my value of the constant of proportionality k, k is going to equal y over x, which in this example, when we simplified everything down, was 2 over 1. So on the graph, that's going to be at the point 1, comma 2. Remember that the x value goes first, the y value goes second. So we just take this data and we substitute them into their appropriate places for our coordinate. Y was 2, x was 1, so this is the point 1, comma 2, which, if we look at our graph right here, that's the point representing k, the constant of proportionality. In our second example, we're told that the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. And so looking at the table, we see the time in minutes and then the distance in feet. And we have to figure out what kind of a relationship we have. And then we're going to graph that relationship underneath. Okay, so for the sloth, we're interested in the feet per minute. Feet per minute. So what we're going to do is now look at our data. And again, our first set of data is 0 and 0. The sloth hasn't gone anywhere, so we're not going to include that. But our next one is 6 feet in 1 minute. So I'm going to put 6 over 1, and that's already a unit rate. So I'm going to move on to my next set of data. The sloth can go 12 feet in 2 minutes. Simplify down to a unit rate. Divide each of those numbers by 2. You get 6 over 1. Our next set of data says that the sloth goes 18 feet in 3 minutes. Simplified down to a unit rate, this is also 6 over 1. Divide both numbers by 3. And then our last set of data is going to be 24 feet in 4 minutes. Divide both numbers by 4. And once again, you get a unit rate of 6 over 1. So this question asks, what is the constant of proportionality k? K equals 6 over 1, or 6. And it means that the sloth goes 6 feet per minute. That is the unit rate, 6 feet per minute. The ratio of time to distance is a proportional relationship. We had the same constant unit rate, so I know that the relationship is proportional. And now what I'm going to do here is set up my quantities as ordered pairs. Remember, I have to ask myself, which is the independent variable and which is the dependent variable? The independent variable is x, the dependent variable is y. So if we look at this back at our table, all right, the distance traveled depends upon how long the sloth has been moving. Okay, so the distance depends upon the time. Distance is the dependent variable y. Time is the independent variable x. And again, if we look at our rates, feet was our y over x, which was our minutes. We set these rates up as y over x. So from our table, our first ordered pair, again, is going to be 0, 0. Our second ordered pair, x, the number of minutes, it goes in 1 minute, it goes 6 feet. Our next ordered pair, in 2 minutes, the sloth moves 12 feet, 2, 12. And then 3, 18, 3 minutes, 18 feet. Followed by 4, 24. In 4 minutes, the sloth can go 24 feet. These are the points that we're going to plot on the graph underneath. All right, so we have our graph here, and we have to set up the graph before we can plot any of the points. Remember, the first thing we do is label the x and the y-axis. The x-axis runs horizontally along the bottom there. The y-axis is vertically right here. That's our y-axis. And now we're going to title them. The x data from our table up above, x was the number of minutes. So x, we're going to put time, and in parentheses, we're going to put the units, which were minutes. And for the y-axis, the y data was our distance in feet. So let's label that over here. This is the distance, and in parentheses, feet, distance in feet. Now we're going to come up with an appropriate scale. Remember, where x and y meet is the origin at 0, 0. All right, if you look at your table for the time, the biggest number of minutes was 4 minutes. So from the origin, I think it's safe to say along the x-axis that we can count by ones. 1, 2, 3. There's our 4th minute. I'm going to label the rest of them, 5, 6, 7, 8, 9, 10 minutes. Now we need to come up with a scale for our feet. And the feet, the biggest number of feet was 24 feet. So again, if we count by ones, I don't think we're going to make it along the y-axis. So let's try counting by 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We could make it up to 26 feet if we needed to, but we only have to go up to 24. Now that we've labeled everything, we've come up with a scale. Now we can plot our 5 points. So our first point was the origin at 0, 0. So we'll put a dot right there. Our next point was at 1, 6. So I'm going to move right 1 unit from the origin and up 6. Our next point was at 2, 12. So I'm going to move to the right 2 units and then up 12. Our third point was at 3, 18. So I'm going to move to the right 3 units and then up 18, which is right here. And then finally, I was at 424, so I'm going to move to the right 4 units and then up 24 units, which is this point right here. And now we're going to draw a line. So I'm going to use my line tool here, and I'm going to connect all of my points with a nice straight line, go through that last point, and then don't forget to put an arrow on the end. Okay, so again, we knew the relationship was a proportional relationship, so what are we noticing? All right, well, the graph is a straight line, and it starts at the origin. And that's great. We needed to have a straight line passing through the origin because those are the 2 key qualities of a proportional graph. If you have a proportional relationship, then your graph needs to be a straight line passing through the origin. And once again, we have to be able to pick out the constant of proportionality, k. Remember that k, that ratio, was y over x, and each time up above when we simplified everything down, we had a value of 6 over 1. So when we create our ordered pair for this, remember it's x comma y, well, the x value right here was 1, and the y value right here was 6. This point, 1 comma 6, represents the value of k. So if we go over 1 up 6, that point right there represents your constant of proportionality. In our fourth example, the cost of renting video games from Games Inc. is shown in the table. All right, so what I've gone ahead and done here is I've listed the ordered pairs. We can see from the table, the number of games was the x variable, which was the independent variable, and the cost in dollars was the y variable, which was the dependent variable. So when we set up the ordered pairs, remember the ordered pairs are always x comma y. So for the ordered pairs, I have 1, 3, one game is $3, 2 comma 5, 3 comma 7, 4 comma 9. This data we are going to plot on the graph underneath. So I've already done a little bit of the setup with the graph. I've labeled the x and the y-axis. The x-axis is titled the number of games. The y-axis is titled the cost in dollars. And I used a scale of each line equals 1 for both the x and the y-axis. So now I'm going to plot my points, 1 comma 3. So I'm going to go over to the right 1 and up 3. 2 comma 5, I'm going to go to the right 2 and then up 5. 3 comma 7, I'm going to go to the right 3 and up 7. 4 comma 9, I'm going to go to the right 4 and I'm going to go up 9. And now I'm going to use my line tool to connect. And what I need to do is bring this line all the way back until it hits the y-axis, which it's going to hit right there on the y-axis. And I can even extend this line a little bit further past that last point. Don't forget to put an arrow on the end. Okay, so question B, they say right here, determine whether the cost is proportional to the number of games rented by graphing on the coordinate plane. Explain your reasoning. Well, we know that for a graph to be proportional, it has to be a straight line, which we could say this is definitely a straight line. And it also needs to start at the origin. And if we look, well, this line is actually starting at this point right here, which is 0 comma 1. That is not the origin. So since this is not a straight line starting at the origin, this is non-proportional. This is a non-proportional relationship because the straight line does not start at the origin. Okay, since it's not a straight line starting at the origin, this is a non-proportional relationship. So when they ask in letter C if there's a constant of proportionality, well, there isn't one. So we're going to say K, it's not applicable, N/A. There is no constant of proportionality when there is a non-proportional relationship. So always look at your graph and figure out if it's a straight line passing through the origin. If it's not a straight line passing through the origin, then this is a non-proportional relationship.